Hey there, class. Mr. Pusky here. Hope you're having a good day so far. We're continuing today with 9.6, which is about identifying symmetry. And so basically symmetry is like if you put a line down the middle, it's kind of a mirror on both sides. There can be like just regular symmetry, like left, right, kind of thing, or there can be rotational symmetry where if you rotate something, it's going to be the same if you rotate it, okay? So, question for you for the warm-up. It says, are these shapes symmetrical? And if so, if you think they're symmetrical, we'll see if you can draw like the reflection lines. Go ahead and give it a try. All right, what do you think? We have a starfish here. Let's see. There's actually 5 lines we can draw to make this symmetrical. Why don't you guys see if you can figure out the 5 lines? So you could draw a line down the middle. You can see it's left, right. That's line 1. We can go like this. Basically from point to like kind of the crease here, we can go ahead and we can do lines like that. All right, those are all symmetry lines, okay? So we have 1, 2, 3, 4, 5. So this is going to be yes, this is symmetrical. How about the second shape? Is that symmetrical? It's not as symmetrical as the last one, which had 5 lines of reflection, but we can actually draw a line right down the middle, and you can see it's going to be the same on top and bottom. So this is going to be yes. All right, sounds good. Let's get going here. So, line symmetry. A figure can be mapped onto itself by reflection in a line. Think mirror for this one. Okay, mirror. And in line symmetry, a line of reflection is a line of symmetry. Line of reflection. Okay. We have rotational symmetry. Basically, if you rotate it about the center, about the what? Center, it's going to be kind of like if you rotate it 90 degrees and it looks the same, that's going to be rotational symmetry. Point symmetry is exactly 180 degree rotational symmetry. And we talked about center of symmetry. It's the center of a figure in a shape that can be rotated. All right, let's go down here. So let's see. Yeah, so we have line symmetry. So you can see that it kind of creates mirror images here. So those 4 lines for that blue square, I'm sorry, not triangle, that blue square are going to have lines of symmetry. So that's basically kind of how it works. Why don't you guys go ahead and see if you can pause the video for example 1 and see how many lines of symmetry you can draw for A, B, and C. Go ahead. All right, for A, this is a rectangle, so if we draw a line straight down the middle, that's going to be a line of symmetry, and also kind of like, oops, that's not really great. And also kind of like this. So they're going to be, we have 1, 2 lines of symmetry. Okay. How about B? This is a little bit tougher. This is a pentagon, right? So we can draw a line straight down the middle. It's going to be create a mirror image. That's 1. Can also go like this. We can go like this. We can go like this. Is that all of them? Almost. We got this one right here. Okay. So basically if you kind of rotate your paper and see if you can draw a line where it's going to be the same on either side, those are all going to be lines of symmetry. So we have 3, 4, 5. We're not going to count this one because we already have the 1 up here, right? So we have 5 lines of symmetry. How about C? C's kind of stretched out kind of pentagon, right? Look at this. What if I go like this? You see how if I draw kind of a line like that, see how it's not like the same on both sides, right? So this one actually only has, because it's kind of stretched horizontally, we only have 1 line of symmetry, right? Because this one really doesn't work because it's not going to be able to be drawn straight and be able to make it the same on both sides. You can see like this point is right here and this point's down here, and they're not really matching up over the line, right? So this one's like right here, this one goes right here, okay? All right, sounds good. Let's talk about rotational symmetry, okay? So what we do is we divide 360 degrees by the number of lines of symmetry, and that's going to tell us how many degrees, what kind of rotational symmetry we have here, okay? So how many lines can we draw here? Let's see. How many lines of symmetry? Well, we can draw straight down the middle. It's going to make a mirror line, and also horizontally like this. That's not great. Let's try again. So we have 2 lines of symmetry, so we divide 360 divided by 2 equals 180 degrees. All right, this is going to be 180 degree rotational symmetry. All right, and also We can also, if it's under 180 degrees, you want to add itself until you get over 180 degrees, right? So if it were like 90, we could do 90, 180, and 270 degree rotations, right? All right, cool. So I want you to write down here, stop adding at or above 180 degrees. Basically, when you get past 180 degrees, it's going to be kind of redundant if you keep rotating. So, but anything under 180 degrees is going to be important, or it's going to be kind of considered rotation. Okay. All right. Let's do this one here. So we're going to do example. We'll do B. Okay. So it says, does this figure have rotational symmetry and describe any rotations that map the figure onto itself? So basically what it means, if you rotate it that many degrees, it's going to look the same as it originally was. Okay, so that's kind of what it means by rotational symmetry, is that it looks the exact same. So if we flip this, right, 180 degrees, right, it's going to be, this part's going to be on the top, and this part's going to be on the bottom, right? But basically it's going to look the exact same. The hourglass, think about this shape like you're flipping an hourglass, it's going to look the same as it was, right? That's what rotational symmetry means, okay? So let's do B here. Let's figure out how many lines of reflection we have. This is kind of a tough one. We have a hexagon here, so let's draw some lines of rotation, or lines of reflection. So we got one down the middle. We got corner to corner. Basically all flat side to flat side. Corner to corner. All these corner to corner and flat side to flat side. So we have 1, 2, 3, 4, 5. We got 6 lines of symmetry, okay? So what we do is we do 360 divided by 6. Equals 60. So this is a 60-degree rotation here. So what then we're going to do is we're going to add 60 plus itself until we get to 180, and then we're going to stop. So 60 plus 60 is going to be, it's going to equal 120. So we got 120-degree rotation would also make it look like the original figure. And then we got 120 plus 60, which equals 180-degree figure. Okay? So, yeah, so what we have here is we have 60-degree, 120-degree, and 180-degree rotational symmetry, okay? And that's it. Once you get to 180 is where you stop. But those are all different. If you rotated this figure 60 degrees, 120 degrees, or 180 degrees, it'll look like the exact original figure, okay? All right, why don't you guys go ahead and try A and C, see how you do. All right, A is a square. Let's draw some lines of reflection. We got 1 here. We got 2 here. We got 3 here, and 4 here. So we got 1, 2, 3, and 4. So we got 360 divided by 4. Which equals 90 degrees. So 90 degrees is where we start. We're not at 180, so we do 90 plus 90, which equals 180. Then we stop at 180. So we got 180 degrees. So it's going to be 90 degrees and 180 degree rotational symmetry. Okay? And that's it. Cool. How about C? What do you think for this one? All right, well, there's actually only one line of symmetry right down the middle. So this one is, so we can't really do 360 divided by 1. It's not going to do anything. It's just 360 here, which means you have to rotate it 360 degrees for it to look like it originally was, which means you're not going to rotate it at all. So this one has no rotational symmetry. Actually, let me write that up here. RS stands for rotational symmetry. Okay. All right. So this one's going to be no rotational symmetry. Need at least 2. Okay, you need at least 2 lines of reflection, okay, for it to work. All right? This one's going to be no rotational symmetry. Okay, and we have some checkpoints. Why don't you guys try 1, 2, 3, and 4, see how you do? All right, how many lines of symmetry does the figure have? This is a trapezoid. We can only split it right down the middle. This one's going to have 1 line of symmetry. How about this? Looks like kind of a square on its side. We're going to have 1 down the middle, 2 at a diagonal, 3 at a diagonal, and 4 at a diagonal. 1, 2, 3. We got 4. Excellent. All right, number 3. How many, does it have rotational symmetry? And for that to be the case, we need to have greater than 1 line of reflection. And then we're going to describe any rotations. All right. How many lines of reflection can we draw here? If we draw one right down the middle, works. We can do corner to corner. Okay, you can rotate your paper and see it's going to kind of, be at an angle. It's going to work, right? So we have 1, 2, 3, 4. So this is going to be yes. It has greater than one line, okay? So it has rotational symmetry. And now what we do is we take the 360, we divide by the number of lines. Divide by 4 equals 90. So then we keep adding 90 plus 90 until we get to 180. So we're going to have 90 degree, 180 degree rotational symmetry. Nice. Awesome. How about number 4? Well, we can only draw one line straight down the middle. And if we only have one line, there's going to be there's only one line of symmetry. Okay, sounds good. So we can't rotate it. We have to flip it all the way around for it to work. All right, now number 5, we have a similar one. See if you can pause the video. This is kind of a tricky one. See if you can figure out the lines of symmetry and also rotational symmetry. Go ahead. All right, number 5, let's see here. So we can draw a line straight down the middle. Basically, like from peak to peak or valley to valley, we can draw a line of reflection here, right? Peak to peak or valley to valley. So how many? It's not going to be perfect, but cool. We got 1, 2, 3, 4, 5, 6, 7. We got 8 lines of symmetry. So we got 360 divided by 8 equals 45. Okay. So then we do 45. We keep adding 45 until we get to 180. We're at 90. So now we're going to do 90 plus 45 equals 135. Not quite there yet. We do 135 plus 45 equals 180. Okay, and we stop there. So we have 45 degree, 90 degree, 135 degree, and 180 degree rotational symmetry. And that's it. So we drew all the lines of reflection, and we talked about what kind of rotational symmetry. And again, like we talked about, rotational symmetry means you can rotate it that many degrees and it'll look like the original shape. All right, that is all I have for you today. Thank you for watching. Have a great day, and we will talk soon.